All right, so what we're doing is we're going to graph relationships. So a lot of the stuff that we teach you guys in high school mathematics, we collect data, we measure things, and then when we measure things, we organize it usually in some sort of a graph, and then we look at the graph, and the graphs tell us things. One of the things I find fascinating is that pediatricians can almost fairly accurately predict how tall you're going to be as an adult based on how tall you are when you're 2 years old. So when you go in and see a pediatrician for your 2-year annual checkup, they have charts, and they'll say, oh, you're going to be this tall when you're an adult. And they're pretty spot on. And basically what they've done is they've collected a lot of data, did some math, and then figured it out. So that's what we're going to do. So let's look at this graph here. According to this graph, this is the distance a delivery van is from the warehouse, and it varies throughout the day. So it starts off here at the warehouse, right? It's zero. It's zero, I don't know, feet, meters, miles, I don't know. But then it drives away, and then it drives away, and then it drives further away, and then it looks like it starts to come back and ends up back at the warehouse. Right? So that's the distance from the warehouse. So segment 1 shows the delivery van moved away from the warehouse. What does segment 2 show? Well, it moved away from the warehouse too because it's further up. So remember, the higher up we go, the further we are away from the warehouse. Right down here, you are 0 units, that's the word units, away. Up here at segment 5, that's the furthest distance away. That's when you're the furthest away. Okay? So it says, based on the time frame, what change in distance from the warehouse is represented by 6? Well, for 6, so first of all, 2 is basically just a little bit further away, right? Do you guys see that? It's just a little further away. It's at a slower speed too, so just say further away. And then say slower speed, because the steepness represents the speed. This is based on the time frame. What is going on with segment 6? Heading back towards the warehouse. Right? And then it says, which line segment shows the intervals where the distance did not change? Any place where it's flat. So it would be 3, 5. Is there another place where it's flat? Look at the graph. 7. And it says, what is a possible explanation for these segments? So if they're not moving further away and they're not moving closer, what are they doing? Yeah, not moving. They're not moving away, they're not moving closer, they're just not moving. Maybe they parked somewhere. Maybe they parked at another warehouse and they're dropping off some stuff and they're unloading the truck or loading the truck, depending on the situation, but they're not moving at all. Okay? So now the next part, it says, explain how the slope of each segment in the graph is related to whether the truck delivery is moving away or moving towards. So I would say positive slope. Remember that a positive slope Misspelled the word positive. In this particular case meant that you were moving away from the warehouse. A negative slope, which was going downhill. You were moving towards the warehouse. Zero slope meant what?
Not moving at all.
Yeah, not moving at all. Very good. Oh, I had Popeyes for lunch. Today's math lesson is brought to you by Popeyes. You know, I was tired. All right, so now let's look at these graphs of these situations. So, for example number 1, they say 3 hoses are filled with different, 3 hoses fill 3 different water barrels. A green hose fills the water barrel at a constant rate. A black hose slowly opened when filling the barrel. And a blue hose is completely open at the beginning and slowly closed. Oh, I see what they're saying. I misread it. So let's identify which one is the green one. So a green hose is a constant rate. Which one looks like it's a constant rate? A, B, or C?
B.
Yeah. B is the constant, right? That's the green hose. What about the black hose? So now the black hose is slowly opened when filling the barrel. So it slowly fills the barrel. Which one do you think is the black hose, A or C?
A.
A. So this is the black hose. And I should probably label this one. This was the green hose.
Can we make white hose? Alright, not to, alright, I did not mean it.
That's
like
okay.
that.
I have evidence of your statement right here on the...
I did not mean it like that.
Well, that's fine. You can explain it to the principal in a second here.
Okay.
So now for the blue hose, what we need to do is it's completely open and then it slowly gets closed. So that's got to be this one by default. But do you see what that does? There's a whole bunch of water coming out and then the water slowly tapers off to fill the barrel. Okay? So it says which graph best represents the amount of water that filled with the green hose. Well, that would be B, right? Since the flow of the water is constant, the amount of water in the barrel should have a steady increase. And so B is that one. Let's see if we're right, though. For part B, it says describe the water level represented by each graph. The water level for A begins slowly and increases rapidly over time. That was, as we said, the black hose, right? And then the water for C came out rapidly and slows down over time. We said that was the blue hose. And then graph A represents the black hose and graph C represents the blue hose. That's basically what we said. Now here's the next one. It says, could a graph of the amount of water in the water barrel slant downward from left to right. So what they're saying is, what if I have a graph that looks like this? I have a graph, right? And I've got time and the water in the barrel. So we'll put gallons over here and time here. And they're saying, is it possible to have it do something like this? And what causes that?
Like the barrel would be leaking.
Yeah, exactly. So, yes, the barrel is losing water, or leaking, as you said, but you could be letting the water out. And it could lose it at a steady rate. It could lose it all at once. It could slowly lose it and then increase over time. In the shape of the graph, the steepness, I don't know why I'm so tired. The steepness of the graph determines how much water it loses. Okay? Any questions on that? I'm going to zoom out a little bit so you guys can write everything down that we've been writing down. I'll let you guys kind of do that.